So here's what we got going on for us today. We have got the SAT from October 2022. Don't ask me how I got it, but we got it. And we are going to do all of it. So let's start with number one. A line models a relationship between body weight, yada yada. What is the predicted weight in kilograms of an infant with a foot length of 9 centimeters? So predicted, that means we're going to the line. 9, that's here. So what is the predicted weight of an infant with that? Looks like it's about to be 7. Boom. So if you got any questions, you can stop me and I'll try to explain them. But if not, we're just going to keep on running. So line segment AC has a length of 120 and contains point B. Got it. So let's draw the picture real quick. We got line segment AC and it contains point B. That makes sense. And it has a length of 120. Also, it's a segment. So should I redraw that properly? Just stop there and show that it's got a length of 120. B is not necessarily in the middle. We actually know that this is that, and we know that this is that. So what is the whole idea? We want to solve for x. Oh, what is the equation? Well, we just add them together, and that's 120, right? And see, by drawing the picture, you can very easily see that. Okay. Next, just a little quick substitution. I guess you can call this a system. All you got to do is you got to make x equal to 4. 4 over 4 is 1. 1 plus 2 is 3. Oh, and then it's how do you write the answer. But see what we get then. We get y equals 3 and x equals 4. So that would be this one. Also, yeah, notice how all those are 4. So we're really just picking the last number. Okay. We just got to graph the line. 2x plus 6. So notice their little dirty tricks on the scale. So the scales are actually even. But when we're looking for a y-intercept of 6, that is going to be here, right? So I always start with the y-intercept when we talk about graphs. So cross out all the ones that don't have a y-intercept of 6. And then look at the difference. Positive slope versus negative slope. We have a positive slope. So, boom. A. We'll check the answers at the end of the section. This is the note calc. It's actually a very short section. So the graph of the quadratic is shown. Which of the following could be that plus 2? So remember, plus 2 on the outside of the function just means the whole thing goes up 2. So this looks like it's going sideways. We're not trying to turn it upside down. And we're definitely not moving it left to right at all. So it's just got to be that one. So see how they just moved it up 2. So the function q is defined there, where x is an integer. What is the value of q of 6? So, I mean, very important. F of x notation, this is not multiplication. This means you're plugging in 6 for x. And also very interesting, look how you're just doing negative 1 to the 6th. So you should have the idea of what happens when you raise a negative number to an even power versus an odd power. Because what's a negative times a negative? It's positive, right? So if we raise a negative to an even power, we're always doing it in pairs. So if it's 6 times, we're going to go negative times negative. So now we're positive again. Negative times negative. So now we're positive again. Negative times negative. So now we're positive again. So if we have a negative raised to an even power, it's just going to be positive. So this is just negative 1 to the 6th is just a positive 1. It's like that whole thing just goes away. And it's just 5. Easy peasy. All right, next. So we can just cancel this, right? Basically. And then say that it's negative 2. What's the value? Negative 2. So they want to kind of trick you maybe with the 4. But notice, like, it definitely can't be 4. Right away it can't be 4. Because you have to do the equation as written. So if you plug in 4, you get undefined. But negative 2, definitely chill. Definitely chill. Definitely works. All right, 8. So it's a parabola. What do you notice first? The parabola is upside down. That means it has to be negative. Cross out that, cross out that. What do you notice now? I notice that the vertex is over at 6, which means it has to be C. Because remember, this done directly to the x value, that's what moves it left and right. All right, so I see this. I see similar triangles. The measure of angle ABC is 60. So not all of them necessarily, right? What is the measure of ADE? So, I mean, we could probably take some time to prove that they're similar, but whenever you see a shape like that, they're pretty much always similar. Oh, they straight up say it's similar. ABC is similar to ADE. Okay, got it. Yeah, so then the angles are the same. That was extremely easy. Weird. Next. This graph, so we're just got to find the slope. So when I think about finding the slope, I try to find two perfect points. So actually, they're super far away, right? It's up here. But what is that then? So when x, it goes up by 80. So remember, rise over run, the run's on the bottom, is 80. This is 30,000. So then what's the slope? This is no calculator, surprisingly. We got to flex our math skills a little bit. So when I'm simplifying fractions, my tip is don't try to go hard and do the big numbers. Like straight up just divide by 2 as long as you can. And because it's just like you can do that quick. If I'm not trying to talk while I do it. As opposed to like trying to do 3,000 divided by 8 right away. That's pretty tough. Did I still mess it up? Yeah, 375. That would be 650. 375. Boom. So I suppose maybe the better way to do it would be to like plug in 10 and be like, let's see, when you plug in 10, you got to get a little less than 5,000. So where would that put us? Either A or B. And then we'd say, well, it's more than half. So then it has to be more than 250. And that would put us at B as well. That'd be probably the quicker way to do it. I always like looking for different ways to do these. Always trying to look for the fastest way. All right, the given equation relates to the numbers p and n, which, so, yeah, we got to solve for n. The answers tell us to do that. So what are we going to do? We're going to go p minus 3 equals 2 over n. I'm going to do the trick that a lot of people often forget, where we flip over both sides of the equation. Just take care of a few steps in one, and then see all we got to do is we got to multiply by 2. Boom. Yeah. Very useful tip. People often forget flipping over both sides of the equation. Otherwise, like, I mean, you would do the same thing. I guess you just switch both of those from here. Yeah, same thing. All right. Very important. If a system has no solutions or infinite solutions, they have the same slope. So right here, all like very, very fast, it has to just be 3 because they have to have the same slope. That's the most important thing to remember. If like no solutions, that means they're parallel. Same solution, that means they're just the same line. In both of those equations, both of those situations, they have the same slope. That's very, very important to remember because things just go by very quickly when you know that. And there's a lot of questions about that. We'll probably see more. All right, here's what we just got to distribute. So that should be easy enough. Remember, the square roots cancel out when you multiply them. Joe was asked to memorize a list of 200 vocabulary words. He was assessed on his memorization in 3 days. On day 1, he remembered all 200 words. Good for him. On the next day, on each of the 2 days, he remembered 10% fewer words than he did the preceding day. That's an asymptote right there, right? Because theoretically, that's a good example of a real-life asymptote. Because, like, theoretically, he would always remember some words if you take this, like, forever, if he forgets 10% every day. But in real life, he probably would get to 0. Also, like, half-lives of like radioactive stuff or non-radioactive stuff, like carbon dating. That's a asymptote. Because the stuff like eventually all goes away to 0, but it does it asymptotically. So if you can be really precise, you can use that to measure how old stuff is. All right, so we just gotta do some quick math, right? We gotta say he started with 200. On day 1, he remembered all the words. He did great. On the next 2 days, he remembered 10% fewer than he did the preceding day. So the second day, he remembered that many words. He remembered 90% of what he had before. The next day, he remembered 90% of that. So the way to do this math is to see that we have 9 times 9, which is 81. Even if forget the decimal. You just go 9 times 9 is 81. You go 2 times 81 is 162. And you just look for the 162. So if you have to worry about the decimal, you can do that once you get there. But, yeah, you don't have to worry about the decimal because there's only one 162. And you never rounded, so it's not like it could be 160. You just ignore the decimal. Ooh, here's a good one. Here's a good one. Here's a good one. So you got to complete the square. How do you complete the square quickly and accurately? So you ignore the numbers. People try to incorporate that. Like, of course it's there, but we don't use it in completing the square. So you just look at the x's. So you know when you complete the square, you've got to write it as something squared, right? The question is, what number goes there? Well, the number that goes there is half of this number. You keep the sign, so -8. And then we subtract some number, whatever that number is, squared. So it's always subtraction. It's not negative because the first one's negative. Because also notice if we squared it, -8 times -8 would just be positive 64 again. So you always subtract whatever that number is squared. And that's completing the square. So notice that that's the same as this expression. So what's next? Now we just do that for the y's. We'll stick with the same color. So we do the exact same thing. We have y, it's -4, so half of that. And then minus that number squared. Let's move it over. So we still have, don't forget that, we still have the plus 32. So let's do some quick highlights. So what are we really saying here? So we have this, the yellow is equal to this yellow. Can you see that? Beautifully. Yeah. The yellow is equal to that yellow. This orange is equal to this orange. And then we still have this little part right here, especially when I squeeze in the equals 0. And so now how are we going to get the radius? Well, how we're going to get the radius is we just have to combine all of our different parts, specifically the number parts. So we have -64 plus 32 is -32. -32 minus 4 is -36. And so the idea is we move that to the other side. So we have that squared plus that squared. I rewrote that wrong, right? I'll change that. Equals 36, but we rewrite that as the radius squared, which is really just Pythagorean theorem, right? Also, look at that little hint. They got 36 and they got 6. So when you see that, you could say, well, there's a good chance we're going to end up getting 36. We just have to square root it to get the radius. So if you had to guess, 6 would be a good guess off the bat. And it ends up to be 6. That's the SAT. It's a mix of little test-taking strategies and actually knowing what you're doing. All right. What positive value is here? I mean, just kind of ignore, like, you just really think about plugging in. You're like, well, if x was 32, 2 times 32 is 64. Square root of or absolute value of positive 64, still 64. All right. What is the slope of the line that's parallel to that? We already said that, right? We talked about that one at the no solution. Similar question. So the equation of line k is that. What is the slope of the line that's parallel to that? It's the same. 7. Dang. If 2/3 p plus 4 is 10, what is 3p? So that, I mean, it's crazy the SAT does that sometimes, especially with a problem like this, where you can't even find 3p. So like what we're going to do is we're going to find p, and then we have to remember that that's not what the problem is asking for. That's why I always say, like, before you actually circle in a problem, you got to make sure you actually answer the question. So we're just going to do it the old-fashioned way. We're just going to subtract 4. We're going to multiply by 3. We're going to divide by 2. 18 over 2 is 9. And then you remember the answer is not 9. The answer is 3 times 9. So it should be 27. I hope y'all are checking my work. I'd hate to make a simple mistake somewhere, although it is expected. Whoa, what is the value of D? Okay, so we just got a FOIL, right? I really hope that doesn't scare us. That, not that though. The idea that we could just FOIL this and like do all that multiplication, do those 6 multiplications. But what I want you to recognize here is that that would take too long. We can literally decrease our time by precisely 2/3. 66%. I was going to say precisely 66%, but precisely 66.6 repeating percent. Because instead of doing 6 of the multiplications, we really only need to do 2. Because look how we want D. We just want the x squared thing. So you got to think, what multiplication are you going to do here to get the x squareds. And that's just a good thought exercise as well. So when we FOIL this out, what will get us x squareds? Right there, 5 times 3x squared. We'll have 15x squared. And where's the other x squared? Right here. Generally, there's only 2. There might be more. You should check and make sure there's more. But that's definitely x squared. Minus 6x squareds. And then, will there be any others? We'll think you definitely can't use x cubed to do it. We got the x times the x, but x times x squared, that won't do it. Yeah, that's definitely the only x squareds. So then, it's 9. Because we end up with 9x squared. Easy enough. Yeah, definitely take notes. I'm glad to hear. Glad to hear this is helpful. Feel free to ask questions when you need to as well. Whoa, is this a non-3-4-5 right triangle on the SAT? How dare they? I don't think I've ever seen that. I guess because you're just doing tangent and stuff. Oh, but if you're doing tangent, you've got a Pythagorean theorem. No way this was the real numbers on the SAT. I refuse to believe they put these numbers on the SAT. No way. Some of these tests aren't accurate. I refuse to believe that they put a 15, 17, whatever triangle on the SAT. I don't know what the other thing is. I'm going to have to do the math. Do I even know 17 squared? I feel like I've guessed at 17 squared many times on stream. I know that 15 squared is 225. I know 16 squared is 256. It's 289, right? That's the next one that makes sense. And yeah, because it comes from 49. Yeah, it's 100 plus 140. You know the trick to square numbers in your head? You know the very important pattern, also for the ACT. The a plus b squared is a squared plus 2ab plus b squared. So if you're trying to do 17 squared, and this is one of those things that when you write it out, it seems much harder, but in reality, it is easy to do in your head. 10 plus 7 squared is 10 squared plus 2 times 10 times 7 plus 7 squared. So that's 100 plus 140 plus 49, which is 289. And you can do that in your head. So what are we going to do here for this problem? We definitely got a squared plus b squared equals c squared. So we know 15 squared is 225. 225 plus b squared equals 289. You subtract the 25, so you add up 4, 6. Very nice. B squared is 64, so B is 8. Swear I've never seen that triple before. But I know that's not true. Alright, well, so there we go. So then what do they ask for? They ask for the tangent of angle x. So tan is opposite over adjacent. The opposite in this case is 8. The adjacent is 15. The answer is 8 divided by 15. And that is a valid answer because you would bubble that in with 4 spots. 8/1, 5. Can't simplify it. Don't try to cancel out an exponent with a multiplied thing. And that's the end of that section. Should we check answers real quick? Alright, so let's start the calculator section of the October 2022 SAT. So this is a recent one. You might have taken this one. So yeah, we're just going to start at the top. We're going to do all of them. So this is the calculator section, but I personally hope you don't whip out a calculator to do 17 times 8. Because you just got to do 8 times 10 is 80. 7 times 8, 56. 80 and 50, 136. 136 plus 13, 149. And so I suppose if you got your calculator out on your desk, it's not that bad to do it, but still. All right, so what is the solution to the inequality? So we got to graph inequality. I'm surprised they got that so easy for us. The solution is just whatever section is shaded. So you just got to look for the point that's in the shaded section. So I'm going to say right here, 5, 0. You can look real quick, make sure none of the other ones are. Yeah, they're all over the place. All right. So Leo's rectangular painting, the Mona Lisa, measures 21 inches wide and 30 inches long. An artist created a scale replica of the Mona Lisa where an equation 21x, 30x gives the area of the replica in square inches. That makes sense. Which of the following is the best interpretation of x in this constant? Oh, so well, x is whatever they're multiplying by. It's like the scale factor. The width of the replica is X inches greater. No, it's definitely not a subtraction addition thing, and it's definitely not specifically with the width or the length, right? Because it's multiplied by both of them. You can see where the 21 and the 30 come from right here. So it's like a scale factor type of thing. The measure of each side of the replica is X times bigger. I like that. Yeah, I like that. The area is X times bigger. No, you can see that the area is not X times bigger because it's X times X. It's X squared bigger. So it's definitely just C. And that hints at the principle of if you double a side length, you quadruple the area. Because if you multiplied the side length by 2, when you think about the area, what is the area of a square? It's the side length squared. So now if you find a new area, it's like that. It's 4 times the last area. So that's really important to remember. If you multiply a side length by x, you're multiplying the area by x squared, which we can see pretty good here with this equation. And you multiply the volume by x cubed, if you kept going that far. Okay, next. What is the value of y? Okay, look, so they show us this is 90 in the diagram. So you definitely ought to know that triangle degrees add up to 180. So you pop that in there, that's 130. That means this has to be 50. And then you also definitely ought to know that straight lines add up to 180. So this is 180 minus 50, straight back to the 130. Very nice. So that's, I guess, a property you can know. That if you have some diagram that's exactly set up like this, which is sort of common, that outside angle is the sum of those angles. Very cool. Dakota and Alex have different babysitting jobs, where each will be babysitting 4 children for the same amount of time. If they charge the same total amount in dollars for their respective jobs, how many hours will each spend babysitting? Okay, so we've got our equations up here. Dakota and Alex work as babysitters. For each babysitting job, Dakota charges $10 per hour, plus a flat fee of $5 per travel expenses. So this is a great example of a linear equation. So how do you deal with linear equations like this? Well, you should always think about them as you have the rate times whatever goes up, so in this case hours, plus exactly what they said, like a service charge or a flat fee or like an initial amount. So in this case, what is that going to mean? We have $10 per hour, so 10x, plus the additional $5 flat fee. So that's for Dakota. For Alex, we can do the exact same thing. Alex charges $8 an hour, plus an additional 4. Is this like a per child situation as well? Oh, additional 4 fee per child. Whereas Dakota doesn't care how many children do it. Oh, interesting. So that's not an additional $4 flat fee. That's $4 times C, $4 per child. He's got $8 per hour and $4 per child. Interesting. Okay. So Dakota and Alex have different babysitting jobs. They're each will be babysitting 4 children for the same amount of time. If they charge the same total amount in dollars for their respective jobs, how many hours will they spend babysitting? So we'll just say that C is 4. So we know that this bit right here is going to be 16. And then we know that the X is the same, the time is the same, and we know the amount of money is the same. So we'll just set those equal to each other. And then we just got to solve for X. So we'll subtract that to that side, subtract that to that side. So 2x is 11. And so X is 5.5. Okay. Okay, I'll take it. All right, so where are we next? Which graph shows a relationship between... Oh, this is the same thing. Between the time that Dakota spends babysitting and Dakota charges per hour. Yeah, so Dakota, that's this equation right here. And so our task is to graph that line. So it's not going to start at 0, actually. A little bit surprisingly, because that's the flat fee, right? So our y-intercept needs to be 5. So let's cross that off and that off. And then let's just look at a point. So let's say on this graph, when we plug in 1, we get 15. On this graph, when we plug in 1, we get 20. And you can see in our equation, when we plug in 1, we should get 15. So that means it should be B. Very cool, very cool. Okay. Line L has a slope of -3 and an x-intercept of 9/2. What is the y-intercept? All right, so I suppose we could draw this out. Me personally, I prefer to just write the equation for it. I would use point slope form, which everybody should know. M times x minus the x value is y minus the y value. So we know that negative 3 times x minus 9 halves is equal to y minus 0. Oh, and then we want the y-intercept. So look at how now to get the y-intercept, that's easy enough. We just have to distribute this negative 3. Look how that's positive. And now it's in slope-intercept form, right? We have our slope of negative 3, and we have our y-intercept right there. That's a 2, if you could believe it. So what is the y-intercept? Also, it's 0, that value, right? Because it's a y-intercept. D. Nice. All right. Next. Table below shows approximate land areas and thousands of acres for 4 national parks in West Virginia. What is the range of the land areas? So range is biggest minus smallest. It's like the distance they cover, the range they cover. So it's that minus that. What's that? 68.5? Yeah. You can use a calculator for that if you wanted. All right, a new data set with 3 values is formed by removing the data from the New River Gorge. Oh, yeah. Oh, yeah, that was way bigger than the other ones, too. How does the mean area for the new data set compare to the mean for the original data set? Well, it's way lower, right? Way lower. We're taking out the big outlier. So the mean is way lower. Is that it? It's definitely not the same. It's definitely not larger. There's definitely enough information. Yeah, it's just way lower. Weird. All right. Notice the scale. Notice they got some stuff cut off. Notice we jumped up way back to the beginning. But now we're back. So, like I said, notice these cuts they got here on both of them. The mass is yada yada. That equation, which the graph will represent this relationship. So, yeah, because we know the y-intercept is like way negative. And so this is hard to tell because look at, again, this big gap. So I would just plug in points. We do have a calculator. See if we can plug in points like without a calculator. I mean, we do have the 100, right? So what's going to happen when we plug in 100 to this? So 5.6 times 100, you go bang, boom. So it's 560 minus 324, which is what? To add up, 236. And it's just quicker without a calculator. So you know that when you plug in 100, you should get 236. So let's see. That one looks pretty good on that. This is definitely no good, right? Should be getting 236 when we plug in 100. We don't have 100, but that's super negative there. Definitely not 236. And again, here, the same thing. It's like way down there. So just by that, it's got to be A. Beautiful. We'll use a calculator when it really makes sense to. It just really hasn't yet. All right, 11. The scatter plot shows a relationship. For how many data points? I ask this so much. It's so straightforward to me. I don't get it. For how many of the data points does the line of best fit predict a greater y value than the actual y value? So I guess here you just have to actually just know what they're talking about here. So the predicted y value is just the line. The actual y values are the dots. So if we're talking about the data points where the line of best fit is greater than the dot. And so you're just talking about the ones that are below the dot, right? I mean, don't miss this one. That's kind of weird that it's like off the bat a little bit. But it should just be 4 of them. Oh, and they were kind and didn't choose 3. Yeah, they didn't have 3 as an option. So, yeah, if they ask a question like that, which they do all the time, they're just asking how many dots are below the line. That's it. Okay. Next. Line K is defined by that. Line J is perpendicular. So perpendicular slopes is actually all they're asking about here. So if that's the slope of one line, to get the perpendicular slope, you just need to know that, so it originally was this, so we need to flip it over and then change the sign. And that's how you get perpendicular slopes. You call it the opposite reciprocal. Okay. Next, in 2015, a certain country had an adult population of 250 million people. Yeah, I don't think I need to read that. The adult population in 2015 was 77% of the total population. Which of the following is the approximate total population? Okay, so when you talk about percents, you've really got to not try to jump straight to the answer. You've got to set up the equation, in my mind at least. So 2015, a certain country had an adult population of 215 million. So that's what they're saying, is that 250 million is the adult population. And then down here, they say that that adult population is 77% of the total population. So we're going to go that X is the total population, and we're going to multiply that by our 77%. So see how we're thinking about, we're taking the total population, taking 77% of it, and that will get us the 250. So now we can see how to solve for X. We need to do 250 divided by 0.77, and that'll get us whatever it gets us, million. That we will bust out the calculator for, of course. So we'll do 250 over 0.77, a nice answer of 324-ish. Call it 320, I suppose. Very cool. Very cool. Is that right? That's a little fishy to me that it's way off. And we didn't use the other information. They're not talking about internet users, though. So that's definitely how you do it. You do the total population times 77%. That gets you the 250 that are the adults. So yeah, that's right. All right, in 2015, which fraction of the adult internet users in this country had access to or more social media websites? In 2015, what fraction of the adult internet users in this country had access to or more media websites? Fraction of the adult users, right? So that's the one thing when you think about these fractions, you gotta think, what is it out of? It's out of 250. Out of the adults, which ones had access to or more social media websites? 60 million internet users, non-internet users, the adult population. 52.8 had access that many websites. So there we go, 52.8 divided by 250. So, I mean, 50 over 250 is like 20%, right? So I'm going to guess that it's definitely A. So how do you actually get this with the calculator? I mean, notice you say if you got 52 divided by 250, that'll get you 26 over 125 precisely. But see how it's 0.208 rounded to 0.21, which is 21 out of 100, right? Decimals, that's 21 out of 100. 21 hundredths, you would even say. And I just noticed as I just round, I was like, this is like 50 over 250, which is like 5 over 25, which is like 1/5, which is like 20 over 100, which is like 21 over 100. Okay, this is cool. So, I mean, this is super straightforward. So this is actually a really nice tip, because this is a problem that might take you a bit, but notice what they want. This is one of the times where they're not asking for X, but that's actually a good thing. Because look at how this right here is what they're asking for. So if we have 10 times the thing they're asking for equals 9 times the thing they're asking for plus 25. If we just subtract this entire thing from both sides. So it's like we have 10 of the thing minus 9 of the thing. Well, then we just got the thing, right? We just have X plus 9 left. And then we just have 25 over here, and there's our answer. So like the other way to do that would be you distribute the 10, you'd combine all your like terms, you'd have to deal with some big numbers. You then have to add 9 to the end, and you end up accidentally answering 16 because you forget to add 9 to it because X equals 16. But in this circumstance, you just realize you just subtract that from both sides. You get exactly what you need. Very good question. Very good question. All right, next. So a biologist selected a sample of adult female Carner blue butterflies at random from a local population. The mean forewing length of the butterflies in the sample is 1.5 centimeters. The margin of error is 1 centimeter. If the biologist wants to estimate that there's a smaller margin of error. So think about smaller margin of error, less error. He wants to be more accurate, right? So, which of the following changes can be made to the study when it is repeated? And can be generalized to the entire local population. Well, if you use a different tool, I mean, that would work, right? He could just use a better tool. What I was going to say was normally the answer for this is have a bigger sample size. Because if you have a bigger sample size, you're going to be more accurate and you're going to need a smaller margin of error. So obviously C is not going to be good because that's cheating. Measuring the butterflies at 2 different times of the day, I don't see why that would do it. Selecting and measuring a larger random sample of butterflies. That is what does it. So the different tool, that's just kind of talking about a different thing. Because that's like talking about your margin of error for each measurement. But that's not what they're talking about here. They're talking about when you do the data, you calculate a margin of error. And the margin of error that you calculate is going to be smaller if you have a bigger sample. That's like AP stat stuff. Or I guess normal stat stuff. Okay, this is what we were talking about earlier with the multiplying the length by something versus multiplying the area by something. So the ratio of a diameter of a circle to its circumference is 1 to pi. Oh, maybe it's not. Well, the diameter of the circle is multiplied by 3. How will the circumference of the circle change? So we actually don't even care about this. It's just the whole idea. So it's actually, they try to make it seem like it's what we were talking about earlier, but it's not. Because if you multiply the length by something, you just multiply the length by something. And the circumference is a length. So if you multiply the diameter of the circle by 3, you're multiplying a length in the circle by 3. So you're also multiplying the circumference by 3. That's really all how it goes. I mean, you can do the math out if you want. If they're talking about how will that affect the area, it would multiply the area by 9, because it would multiply the area by 3 squared. But with the circumference, that's just also a length. And you can see, because if like the diameter was 1 to pi, oh yeah, and we're not even talking about different circles. We're talking about just the definition of pi. Yeah, that's definitely 3. Because if you multiply a length by something, you're just multiplying the length by something. It's going to change the same way. Okay. Also, if you have a better instrument, you have less margin of error. Yeah, it could be, but that's just not what they're looking for here. Like I said, that's just like not really what they're talking about. Hang on. Both of the changes should be made. Well, you can only choose one answer. I think we definitely chose the best answer, but we can look later. The bigger sample is more important for what they were talking about. All right, let's find the perimeter here. So I guess the biggest thing is we just have to find these 2 extra sides. That's really all we're missing. So how are we going to find those sides? So we're going to look at this whole bit and this whole bit as the idea. So we're going to say that that whole bit is 11, which means that this whole bit has to be 11. And then we're going to see that this is 8 and 2, which means that these things added together are 1. And is that actually all we care about when it comes to the perimeter? We don't even need to know what they specifically are. And plus, we just really need to know that whole side. So we know that that whole side going down is 11. This whole side going up is 11. We are going to have some extras going sideways, though. So then we got 11 plus 11. And then what? We've got this 2.5 and this 2.5. So that's plus another 5. We've got this 2.5 and this 5. So that's plus 7.5. This 7, and then also this bit here. Circle so don't forget. What is that bit there? We've got to do the same deal the other way to find that. So, gotta say, what is this? This is 9.5, and that's 5, so that means that's 4.5. So then we add on a last 4.5, I think. So what is it then? That's 12. That's 7, so 19. 11 is 30. 30 is 41. 5, 46. I hope I did that right. I definitely didn't miss something because that's the biggest answer choice there is. So I think that should be good. We'll check the answers at the end, of course. Okay, this is important. So people kind of forget what frequency means. So frequency just means how much they come up. And actually, look at here. The frequencies are equal for everything, right? So this is kind of a problem. It's going to be a little different than the other ones. So which statement best compares the mean and the standard deviation? So standard deviation just means how much things deviate. What does deviate mean? Who's a deviant? Someone who's different than other stuff. So we're talking about how different everything is. And look at here, since the frequencies are all the same, it's like everything is spread out just as evenly on both of them, right? So normally I'd say for like the standard deviation is always the same. Because unless they're exactly equally spread out, the standard deviation will end up being different. But here, since they're exactly spread out, the standard deviations are actually equal in this case. So we're talking about standard deviation is B and D. So B and D should be equal because they're equally spread out. And then talking about the means, we just got to look at the one that has the higher values. This one's got the higher values, right? So the one for Q should be higher. So that's C compared to A. C should be higher than A. So that's this one, B. Yeah. So pretty much always the standard deviation is different. But in this case, it's just that they're exactly equally spread out. The standard deviations are actually equal. Okay. I already see the 3, 4, 5 idea is probably going to happen. The circle has a center at -1, 1. Oh, maybe not. The line T is tangent to the circle at 4, -3, 5. Which of the following points also lines on the point T? Whoa. So we have to be finding the slope of this line. And then we have to know that these are perpendicular because that's how geometry works. And we have to know that other thing that we said earlier, that the perpendicular slopes are opposite reciprocals. And then we have to use that slope to find new points on the line. That's kind of crazy. But we can do that. That's actually not that bad. So we'll say how far is the rise from 1 down to -3. So it's going down 4. How far is the run from -1 over to 4? It's 5. So that's not a 3, 4, 5. But the slope is 4/5. And we start at this point here. So we just want to say, oh, so that slope is 4/5. No, it's -4/5. It's down 4 over 5. So the slope of this line is positive 5/4. So if we're just trying to name new points, what could we say? We could say that we could go up 5 and over 4. So if we went up 5, -3, up 5, now we're at 2. 4 over 4, now we're at 8. So that's a point on the line. There's a lot more, of course, but that is the answer choice. So that was kind of involved. You had to find the slope of the line, use that to find the slope of the new line, use that slope to find new points on the line. Luckily, the first new point we found was an answer choice. All right, so here we're looking for y. Notice how this is just beautifully set up for us already. If we just add these straight off the bat, the 3x's cancel out. And that's the whole point of solving systems of equations most of the time, is you cancel out one of the variables. So we just end up with a clean 2y equals 15, and y is 7.5. Don't even need to find x, because they do indeed ask for y. You should go back and check and make sure at the end you're solving for the right thing. All right, man, we have not used the calculator very much here. So a researcher estimates that there's a population of that many gray wolves, which covers that much miles. Which of the following is the closest to the gray wolves per square mile? So remember, per means division. So we're just going to set this up how they give it to us. We're going to go, we want gray wolves divided by square miles. We want 618 divided by square miles. And so we just pop out the calculator. 618 over 16,452. It's another problem with calculators is you can type min wrong. But you end up with 0.03. That's small. That's an answer, 0.04. Yeah, you just got to round them. And that makes sense, right? It's very not dense. There's only 618 square wolves in that many square miles. There ain't that many wolves in every square mile. It'd be more normal to do square miles per wolf. But that is not what they're asking for. All right. So in the xy plane, how many x-intercepts does that graph have? Well, so it's got one here at 0, it's got one here at 4, and it's got one here at 5. It's got 3 of them. So you might be tempted to say that it's got 6 because you like add these exponents. But remember, double roots and triple roots, it's only one x-intercept. It's not multiple x-intercepts. So there's only 3 x-intercepts here. Oh my god, there's a chapter book on the test. Let's just read the last question. How should the experiment be changed to allow the researcher to conclude whether supplement has an effect on plant growth? Oh, so we got to read the whole thing. The effectiveness of a mineral supplement in the soil on the growth of a particular species of plant is being studied. A botanist planted 1,000 seeds in a greenhouse so the growing conditions for all the seeds would be as identical as possible. The seeds are obtained from 2 50-seed packages. The seeds from one package were planted in the soil that had the supplement added. The seeds from the second package were planted in the soil that did not have the supplement added. How should the experiment be made better? So this is kind of subtle. Because in real life, you might think that this is pretty good. But in reality, the issue is that the seed packages, like one of the seed packages could have had something wrong with it, right? And so like we might just assume that those seeds didn't grow, but it turned out that it wasn't because of the supplement, it was because the seed package was rotten. So what we need to do is we need to randomly assign the seeds. That's very important when you get to experiments. You need some sort of random assignment. Even if it seems silly and that you could just kind of pick it out yourselves. Like, no, it really needs to be a random assignment. So that should be the problem. Half the seeds from each package should be randomly assigned to each soil type. You can't have the one package going to one soil type and the other package going to the other soil type. Because then you don't know if it's because of the package or because of the soil type that's the problem. When you're doing science, you've got to limit it down to one thing that's different. Not 2 things. Okay. Researchers estimated that 0.07% of mass of a 12-gram sample of an orchid plant consists of the fatty acid. That acid. Based on this estimate, what is the mass of that acid in grams of the orchid sample? So you're just doing a quick multiplication, right? And you're realizing that when we have 0.07 as a percent, I mean, you could probably just type in the percent sign, but that's probably not good for you. I would just think about moving over the decimal. Suppose you could also say that it's division. Percent is out of 100, so it's 0.07 out of 100. Don't be afraid when your calculator does that. It's the same thing. And you get that. And that makes sense that it's really small, right? We're talking about like a literal acid that's like part of the orchid. It should be very small mass. And so there's probably percents in here, but you don't need to go looking for that. Probably be in arithmetic. Well, maybe not. Good. So yeah, there we go. Yeah, this is the SAT. This is the October SAT. Like I said at the top. All right. The population in millions of Suzhou, China can be modeled by that function, where t represents the number of years after 1990. So they want us to write a new equation that represents the years after 1995. But we want it to follow this exact same equation. That's the idea here. So what should we think about? I mean, really, there's a few ways we could think about it. My initial way of thinking about it is to say, well, when we plug in 5 into this equation, that means we're finding whatever the population for 1995, right? Because this equation uses years after 1990, which means in our equation for 1995, we should plug in 0 and get that same number, right? Because if our equation is for years after 1995, in 1995, that's 0 years. later. So when we plug in 0, we should get the same thing as when we plug in 5 up here. And so I would start with, like, what is that true for? Well, so when we plug in 0, all of this would just go away, for those at least, right? But it's not, like, this 1.1 to the 5th is never going to happen, right? It's 1.1 times 1.066 to the 5th. That 1.1 is not also raised to the 5th. And then here, if we made this 0, you'd end up dividing by that, right? So that's not right either. And here, if you made this 0, this whole thing just goes away here, and you just have 1.1, and that's not right either. So just based on that, it has to be C. And that is my normal technique for these, is you got to think about plugging in a certain number, and it's got to work for, like, both the things you want it to work for. Yeah, this is the one that gets you into college. You take this or the ACT generally. So the other way to think about this, probably the better way to think about this, is that the growth rate should be the same. So that's why you still have 1.066 to the end, because the growth rate is still the same. It's the initial condition that's new. And look at how they calculated the initial condition just by using the above formula. By plugging in 5 to the above formula, because that gets you the population in 1995. So this thing here in the square is just the initial population, the population in 1995. All right. I'm going to take a quick little break. I'll be right back. I'm going to pause the recording too. Shoots. I keep stopping the recording. What do we got here? We got that the equation has exactly 2 solutions. So what do you do when quadratics are talking about how many solutions they have? You do the same thing every time. So you think about the quadratic formula, right? Which part of the quadratic formula tells you how many solutions there are? It's the part inside the square root. It's the b squared minus 4ac. And so if that is greater than 0, then we're going to have the square root of something positive, right? And so that'll be okay. The problem is when it's negative, then we'll end up with no solutions, no real solutions. And if it's equal to 0, then we'll have plus or minus 0. And that'll just end up being one solution, b over 2a. So this is the gist of it. We need b squared minus 4ac to be greater than 0. And so we're just going to plug in the numbers that we have. We know that 36 minus 4 times 1 times c has to be greater than 0. And now we just have an inequality. We can just solve for c, get c by itself. Add 4, divide by 4, add 4c, divide by 4. We get 9 is greater than c, or c is less than 9. And actually, we just picked that answer, right? I thought we were going to have to pick a specific number. I thought we were going to have to pick a number less than 9, but that's what they're looking for. C is less than 9. So discriminant. And notice that's with a quadratic. If they're talking about how many solutions you have with a quadratic, you do that. If they're talking about how many solutions you have with a system of equations, you think about what we said earlier, about the slopes being the same or not. All right. So we're trying to write the equation for this line. So I always start with the y-intercept. I will say the y-intercept looks like it's basically 0. It's definitely not 10. It's definitely not 90. So then we just think about the slope. Or we just think about plugging in a point. So I would say it sure looks like when we plug in 0.1, we should get something very close to 10. So if we plug in 0.1 into b, 10 times 0.1 is 0.1. 0.1 times 1.5 is definitely not close to 10. Versus this one, 9 times 0.1 is not 90 times 0.1 is 9, plus 1.5 is approximately 10. So when we go with A. So it's amazing how useful plugging in points is. All right. This is kind of a cool question. So what are we going to do here? We're going to have a small piece of paper cut 2 times, resulting in 3 smaller pieces of paper, right? So we're starting with paper. We're going to go cut. Now we got 3 pieces of paper. Then the 3 smaller pieces of paper are stacked and cut 2 times to form 9 even smaller pieces of paper. We can do that for ourselves by going the other way. cut, cut. Now you can see we have 9 pieces of paper. This process continues until the pieces of paper are too small to cut. There's an asymptote, in a way, because they're going to get closer and closer to 0. Which of the following gives the number of pieces of paper that results after C cuts, where C is an even number? So here's what I would start with. I would start with the fact that we already have some values, and we're just going to plug in points. We're going to say when we have done 0 cuts, we had 1 piece of paper. When we did 2 cuts, we had 3 pieces of paper. And we did 4 cuts, we had 9 pieces of paper. So I'm going to start by just plugging in those values. So when we plug in 0, that's the easiest. We should get 1. We do in A. We don't in B, though, right? We would get 3. We would in C, and again, we would not in D. We would get 3. And then we'd plug in 2, and we need to get 3. So if we do that in A, 3 to the 2 over 2 is 3 to the 1, which is 3. We do that for C, 3 to the 4 is 81, not 3. So it's not that. So it's A. So, yeah, plug in points. Understand the situation. Figure out the exact numbers that you already have. Plug in the points. Okay, there are 640 acres in a square mile. The area of a forest is increasing at 1 acre per decade. Which of the following is closest to the rate at which the area is increasing in square kilometers per decade? Okay, so here's what we're going to do. It's the square that's going to be the problem we have to realize here. So this is dimensional analysis. We start with what we have. They tell us that we're going at 1 acre per decade. And what do we have to end up at? We have to end up at square kilometers per decade. So here's what's going to happen. We're going to start with our simple, we got to cancel out the acres. And we know that there's 640 acres in a mile. So look how, just like division, acre divided by acre, the acres cancel. Now we're in miles per decade. Except for that's not right. This is miles squared. So 1 acre is 640 square miles. So now we're in square miles per decade. So the issue, not the issue, the hard part, the part to pay attention to comes in here. Because now we're not just canceling out the miles, we're canceling out the square miles. So we have to multiply by kilometer per 0.62 miles. So that cancels out one of the miles. And then we have to multiply by another kilometer 0.62 miles. So then we cancel out the other mile. And look at how that's what gives us kilometers times kilometers. That's what gives us our kilometers squared. So that got a little messy, but it's okay, because now the whole point of this dimensional analysis is we just have to look for the numbers, because we know we got our units right. So what we end up with, we actually have no numbers on the top, right? So it's just a 1 on the top. And on the bottom, we have 640, then the 0.62, and then the 0.62. So we just pop that into the calculator. 1 divided by 640, 0.62, 0.62. Should be 0.0041 D. Very nice. Dimensional analysis is important, and when you got a unit squared, you can't forget about the unit squared. That's definitely the mistake that people are going to make. All right, we're making good time with this. On to the last one. So an observer counted the number of paddle boats. The scatter plot shows the data. How many paddle boats were counted at 2 p.m.? All right, easy enough. You go 2 p.m., we're talking about that place right there. It looks like 7. Over here, a company spent a total of $9,000 on digital print ads. The ratio of money spent on digital ads to money spent on print ads was 1 to 3. Ooh. How much money in dollars did the company spend on digital ads? Okay, so we're talking about ratios. So we can say that digital ads to print ads was 1 to 3. That's what they told us, right? And they also told us that digital plus print ads together was $9,000. So we just got a little system of equations. What we'll do up here is we'll cross multiply. So we'll get that 3D equals P. And then what do they want? They want the digital ads. They want D. So this is perfect. We'll do substitution for P. We'll get rid of P because 3D is equal to P. So down here what we have is D plus 3D is 9,000. So you combine, you get 4D, you divide by 4. You could use a calculator. Probably quicker to just half twice because you get 4,500 and then 2250. And so you can check it real quick for yourself. If you wanted to multiply that by 3, what's that by 3 is 6,750. And if you add those together, you do indeed get 9,000. So that is the right answer. All right, I'm feeling good. Almost too good. I'd be honestly a little surprised if I got them all right. Just running through them here. I should know how. I mean, I do know how to do them all, but I feel like I generally make mistakes. We'll see. A solution to the given equation is that. What is the value of k? So this looks a little weird, but how do you get a square root from a quadratic? Well, it's definitely the quadratic formula, right? So let's do the quadratic formula for this equation. You can kind of see you can't factor anyway. So let's do the quadratic formula. So we got negative b, negative 2, plus or minus the square root of b squared minus 4ac, but the c is negative 1, so plus 4 over 2. And so look, that's where they get the negative 1, because now we're simplifying things. So 4 plus 4 is 8. Square root of 8 is 2 root 2. So this is negative 2 plus or minus 2 root 2 over 2. And then now if we hard it, since both of these things have a 2 in it, they both cancel. So we end up with negative 1 plus or minus root 2. So what is k? The number inside of the square root. In this case, that is 2. Yeah, easy enough, right? Okay, what is next? I guess we're just going to go to the calculator here. If a temperature is increased by that many degrees Fahrenheit, how much did the temperature increase in degrees Celsius? So here's what I would say here is if they're just talking about how much it increased, that means we don't really care how it starts, right? So, and we have a calculator. So I would just say if a temperature increased by 0 degrees Fahrenheit. So what if it was 0 degree or by 19.8 degrees Fahrenheit? So what happens when it's 0 degrees Fahrenheit? What happens when it's 19.8 degrees Fahrenheit? And then we just bust out the calculator. So if we plug in 0 to this equation for x, we have 5 times 32 divided by 9. You see we get 17.7. And then if we plug in, what was it, 19.8? Yeah, if we plug in 19.8 into this equation, 5 over 9 times 19.8 minus 32. Oh, I messed up on the negative before, right? That should be negative 17.7. You do it this time, you get negative 6.7. So how much did the temperature increase by in Celsius? Well, it went from negative 17 to negative 6. So it went up by 11. Okay. I'll take it. I'll take it. Whoa. The figure shows 2 rectangles. If a point within the figure is selected at random, boom, what is the probability that the point is within the shaded region? Well, so that one wasn't right, but maybe if we went randomly again, that one was. So what we need to do here is you need to think about like the ratios of the area, right? You need to say we're randomly putting a point inside of the big rectangle. So we're randomly putting the point in 35 square inches of area. But what is the area that we're really looking for here? Well, not the white rectangle, right? So anywhere inside of the big rectangle, except for the area of that little rectangle, is what we want here, right? Because we want the probability of the shaded region. So the area of the shaded region is the big region minus the small region. So 20 out of the big region, 35. You can't graph that, or you can't grid that. You do have to simplify, cancel out the 5, 4 out of 7. There we go. In the given equation, Q is a constant. The equation has no solution. So if it has no solution, What that means is we're going to want this to like cancel out. Because see, if that all just cancels out with each other, we get 0 equals 36, and that's wrong. And that's what happens when you get no solution. So we're just going to say that like this -9 plus this 24 times q, that has to cancel out to be 0. Because that will cancel out the left side. And now we can just solve for q. We can add 9 and divide by 24. And that seems like a crazy answer, but that's perfectly griddable. 9/2, 4. That's definitely the answer. All right, last two. The value of r is 20 over 21 times the value of t. We can write that. The value of r is 20 over 21 times t. The value of t is what percent greater than r? So see, this is my thing. This is why I'm saying, like, don't try to go to it right away. You got to set it up. So look at what you're looking for here. You're looking to solve for t. So what they're saying then is they want to move this to the other side. So you could use a calculator for this if you want, but you got to multiply by the reciprocal. So what we're going to get is that t is equal to 21 over 20 r. And so you look at, that's what the x is. But that's not the answer. You get the hint, but you can't grid that. Because they just want what percent more is it, right? So if you put that in the calculator, you can see that like 21 over 20 is 1.05. And then when they talk about percent more, that means you have the beginning amount, the 100%, plus some percent. In this case, 5%. So that is the answer. And not 0.05, because they show you right here, if it's 39%, put 39. In our case, it's 5%. So we will answer 5. A previous problem again? Like this one? Yeah, you can take a look at it for a second. The last problem of the day. Two numbers, a and b, are each greater than 0. And 4 times the square root of a is equal to 9 times the cube root of b. I love when it like sounds so complicated, but it's literally just, you straight translate it. 4 times the square root of a is equal to 9 times the cube root of b. If a is 2/3, for what value of x is a to the x equal to b? For what value of x is a to the x equal to b? So you can see what we want then. 2/3 to the x is equal to b. Yeah, that's what we want. We want to simplify this into 2/3 to the x is equal to b. So there are actually kind of a lot of problems like this. And I feel like the technique, anytime you have square roots and cube roots, is to switch it into fraction exponents. So what is that going to be then? That's going to be 4 times 2/3 to the 1/2, right? Equals 9 times b to the 1/3. And so what we're going to have to do is we're going to have to end up like combining stuff. Because look how we definitely want to get b by itself, right? So I'd say the first thing we should do is we should cube everything. Raise everything to the 3rd power, because then when you multiply these exponents, you'll just end up with b. And then in the meantime, the other trick we're going to want to do here, which you kind of see with the 2/3, and look how that's 2 squared and that's 3 squared. So let's change those as well. And that'll actually help, because I don't really want to try to think about 9 cubed. But if I think about 3 squared cubed, that's 3 to the 6th. And same deal over here. This is going to be 2 to the 6th. And then here, 1/2 times 3 is 2/3 to the 3 halves. So yeah, just exponent rules. And now what? We still want to get b by itself. So that would make me think that the next step is definitely just divide by 3 to the 6th. So then notice, look what we have here. We have 2 over 3. They're both raised to the same power. So we can rewrite that as 2/3 to the 6th. And then that's going to be multiplied by 2/3 to the 3/2. And now look at that. Now we have the same base. We can just add those exponents. So we go 6 plus 3/2. 6 times 2 is 12, plus 3, 15. 15/2. So this is 2/3 to the 15/2 equals b. And so you remember again what we were looking for. We had this equation. We were looking for what that exponent had to be. And now we see that it's 15/2. That was a lot of work for that question. And yeah, that should be it. I'm going to check the answers real quick. But for the video, if you got any questions, throw them in the comments. And if I didn't get any wrong, which I shouldn't have, this should be the end of the video. So it looks like I got one wrong. 14 is not A. So let's try to see what we did wrong here. What fraction of the adult internet users in the country, so of 250 million, of adult internet users. That's the mistake we made. It wasn't out of adults. It was out of adult internet users. So it's not out of 250. It should be out of the internet users, of which 160 were internet users. It should be 52 out of 160. Which, yeah, looking at that is definitely... definitely B. So, like I said, I do make some mistakes. Not on the math necessarily, but on the reading close enough, unfortunately. But hopefully that's the only mistake. Fingers crossed. Yep, that was the last one. And so all that comes down to is you just got to slow down and read the question. So I hope that was helpful. And I hope you come back and check out the next one.